Hello students, today we are going to discuss some compounds of halogens like chlorine, hydrochloric acid, oxoacids of halogen, interhalogen compound. So first we'll start with discovery of chlorine. So chlorine was discovered in the year 1774 by Carl Wilhelm Scheele by the action of HCl with manganese dioxide, okay, which give manganese chloride, chlorine and water. Now it was Davy who established its elementary nature and suggested the name chlorine on account of its color. So chlorine, chlorus, it derived from the Greek word chlorus, meaning green yellowish color, and we know that the color of chlorine gas is greenish yellow. Next, so let us first discuss the preparation of chlorine in laboratory. Okay, now so chlorine gas, so as already been discussed, that it is prepared by heating manganese dioxide with concentrated HCl. Okay, when the two are heated, then what happens is it gives manganese dichloride, chlorine main product and water. So in this reaction, okay, so this concentrated HCl, this HCl can be replaced by mixture of NaCl and sulfuric acid. So if you react manganese dioxide with mixture of sodium chloride and sulfuric acid, okay, then you will get chlorine gas as a product. And what would be the byproduct? So manganese with chlorine will get manganese chloride, okay, then sodium is there, sulfate is there, so it will form sodium bisulfate, then it gives chlorine gas, and hydrogen is there, so hydrogen will remove as water. So this is the reaction which gives the productions, or which is used in the productions of chlorine gas. Now next is chlorine can also be prepared by action of hydrochloric acid with potassium permanganate. So KMnO4, okay, and HCl, so it will combine to give KCl, so manganese chloride and water and your chlorine gas. Now your potassium permanganate, okay, it reacts with HCl. So when we do the titration, okay, of your KMnO4, right, so we use the sulfuric acid there. We cannot use HCl. Why? Because when HCl you react it with, or when you add to the potassium permanganate in order to make it acidic, okay, so this permanganate will get reduced to manganese chloride. So for that reason, so we cannot use HCl in order to acidify KMnO4 during titration of KMnO4 with ferrous with more salt or with oxalic acid. Now next we'll discuss, okay, industrial manufacture of chlorine. So in this chlorine can be manufactured industrially by Decon's process. Now in this process, okay, your HCl will get oxidized. So HCl is oxidized in presence of catalyst copper chloride, and it gave chlorine and water as a main product. So this is one way of preparing chlorine industrially, Decon's process, and here the catalyst used is copper chloride, and the other process is electrolytic process, that you have already studied, right, in your previous chapter. So in electrolytic process, okay, so electrolysis of brine solution means your aqueous solution of NaCl will gives out chlorine gas as a product. Now what happen is in this process, okay, so your chlorine gas will be collected at anode and your hydrogen gas will be collected at cathode. Now the two solutions are separated by a membrane, which because of which you will get this chlorine gas and hydrogen gas separately. And the byproducts is your sodium hydroxide, which will remain in the solution. Now this is the brine solution which contain your sodium hydroxide 33%. Now properties. So its color is greenish yellow. So for that reason the name given to is chlorine, right? Now it have pungent and suffocating odor, and it is 2 to 5 times heavier than air, so it can easily be liquefied, okay, and you'll get is a green yellow liquid. It have boiling point to 39 Kelvin, and this is highly soluble in water. Now chlorine reacts, okay, with number of metals, non-metal to form chlorides. For example, it reacts with sodium to give sodium chloride. It will react with metal like aluminium to give aluminium chloride. Okay, it will react with iron to give ferric chloride. It reacts with non-metal like sulfur, phosphorus to give respective halides. Okay, so that means your chlorine is reactive, highly reactive. So this chlorine has high great affinity to with hydrogen. So for that reason it reacts with compound containing hydrogen to form HCl. Okay, like chlorine, hydrogen and chlorine, it give HCl as a product. So when it reacts with hydrogen sulfide, okay, again it give hydrochloride. And your hydrocarbon, okay, then what happen is it will give hydrochloride and your carbon. So your this chlorine, okay, reacts with compound of hydrogen to give hydrogen chloride. Why? Because it has great affinity with hydrogen of a hydrogen. Now this chlorine reacts differently with hot concentrated alkali, cold dilute alkali. Let us see how. So ammonia, okay, sorry, sodium hydroxide. So let this be cold and dilute, and chlorine. When the two reacts, when chlorine is passed through cold dilute sodium hydroxide, then what would be the product? So it will give sodium chloride salt and sodium hypochlorite. So this is your sodium hypochlorite. Okay, and same again chlorine gas, if it is passed through so concentrated, okay, hot sodium hydroxide solution, then you will get different product. So sodium chloride and sodium chlorate. Okay, so cold र dilute मा इले के दिन्छ sodium hypochlorite NaOCl दिन्छ, and concentrated र hot मा के दिन्छ इले sodium chlorate दिन्छ NaClO3. okay, rest तिम्रो NaCl र H2O same हुन्छ. So that means the reaction with your nature of solution like concentrated or hot or cold, okay, it will give different product. Now next with slaked lime, it give bleaching powder. So what is your slaked lime? Calcium hydroxide, right? So when you pass this chlorine gas through this sodium slaked lime or calcium hydroxide, so what you will get is bleaching powder of formula CaOCl2 and byproduct calcium chloride and water. Now the main composition of bleaching powder is it contain CaOCl2, okay, calcium chloride and your calcium hydroxide and water. Okay, so this is the formula or composition of bleaching powder. Calcium oxychloride, then calcium chloride, calcium hydroxide, and water. So this is the composition of bleaching powder. So this chlorine with hydrocarbon give a substituted product. So you have already done in junior classes or in 11, right? So whenever you react methane with chlorine in presence of sunlight, then what happens is substitution reaction will occur, a chain reaction will occur. Okay, so what happens is chlorine will replace hydrogen, so you will get mixture of your product. So not one but many, right? Mixture of product you will get. And also your unsaturated, if hydrocarbon is there, then chlorine will give addition product, like chlorine will go to the double bonded, each double bonded carbon atom, so you will get CH2, single bond CH2, then Cl. So with every addition of one molecule, okay, so there will be a breaking of a bond, one bond will break. So again this chlorine water, greenish yellowish color it have, right? But on standing it loses yellow color. Why? Because chlorine water, whenever the two react, it gives hydrogen chloride and hypochlorous acid. Now why this hypochlorous acid will then again decompose to give HCl and oxygen. So this is what called nascent oxygen, very reactive species. Okay, now so because of release of or production of this nascent oxygen, this chlorine in water is strong oxidizing agent and have bleaching property, and hence your chlorine water on standing loses its yellow color. Now chlorine is strong oxidizing agent because it gives out nascent oxygen and it oxidizes, okay, ferrous to ferric ion, sulfite, okay, to sulfate, then sulfur dioxide to sulfur trioxide, iodine to iodate, etc. For example, so ferrous sulfate, okay, on reaction with chlorine in presence of acid, it gives is it will get oxidized, ferrous will oxidize to ferric, भनेपछि Fe2SO4 whole 3 you will get, and HCl, self will reduce to HCl. त्यसरी नै SO2, okay, so के हुन्छ chlorine सँग react गर्दाखेरि water, chlorine water, right? So SO2 will now oxidize to SO3. So के पाउँछौ तिमीले SO3 पाउँछ, okay, and or here it will oxidize to sulfuric acid and HCl. त्यसरी iodine केमा convert हुन्छ iodate मा. So chlorine will oxidizes this iodine to iodate. So this your chlorine, that means your chlorine is a strong oxidizing agent and it is because of production of this nascent oxygen. And again, so chlorine, water, it gives it HCl, hypochlorous acid will decompose to give nascent oxygen, and because of this, so it is also a powerful bleaching agent, and the bleaching action is due to oxidation. Okay, it bleaches vegetable or organic matter in presence of moisture. जस्तै किन moisture मा भन्दाखेरि अघि नै यहाँ छ, so यसलाई simply हामी if we write के हुन्छ H2, if we combine the equation, right? So हामीले पाउँछ this two combined U2HCl and it gives nascent oxygen, and this nascent oxygen will oxidize colored, okay, substance to colorless. So bleaching action of chlorine is because of your nascent oxygen. Now since the bleaching action of chlorine is because of oxidation, so for that reason bleaching effect of chlorine is permanent, okay, whereas bleaching action, so see this sulfur dioxide is also a bleaching have a bleaching property, but it's not permanent. Why? Because the bleaching action of this sulfur dioxide is because of presence of nascent hydrogen or because of reduction. भयो सो त्यसले गर्दाखेरि सो SO2 को जुन चाहिँ ब्लिचिङ इफेक्ट छ सो द्याट इज टेम्पोररी ओन्ली नाउ नेक्स्ट युजेस ओके युजेसमा तिम्रो ब्लिचिङ it is used to bleach okay wood pulp cotton textile and it is also used in extractions of noble elements like gold platinum and it is used in manufacture of dyes drugs organic compounds such as DDT okay carbon tetrachloride CCl4 etc refrigerant and it is also used in sterilizing water and it is used for preparation of poisonous gas like phosgene okay tear gas mustard gas so these are the uses of chlorine gas. Now let us discuss hydrogen chloride okay in the year 1648 so it was Glauber who prepared acid okay on reaction or in heating your sulfuric acid with sodium chloride and Davy again okay so in 1810 showed and proved that the hydrogen chloride is a compound of chlorine and hydrogen and it bleaches vegetable or organic matter in presence of moisture. So bleaching effect of again HCl is permanent. Now next preparations as we have already done right discussed so this HCl can be prepared by heating sodium chloride and sulfuric acid. So first you will get okay sodium bisulfate and HCl which is our product. Again sodium bisulfate will react with sodium okay to give sodium sulfate and hydrogen chloride. So hydrogen chloride can be this gas can be dried by passing through concentrated sulfuric acid. So as we have already discussed that concentrated sulfuric acid is used as dehydrating agent or it is used in drying some of the gaseous right. So now properties haru देखेकै छ तिमीले ल्याबमा हैन कलरलेस हुन्छ pungent smell हुन्छ नाक पोल्छ then यसलाई easily liquefied गर्नु सक्छ boiling point because 189 Kelvin मात्रै छ र it freezes okay to give a white crystalline solid and it will give colorless liquid and freezing points are 159 Kelvin right it is extremely soluble in water so त्यसले गर्दा तिमीले के देख्छ so you will get dilute HCl in lab right it ionizes like HCl water छ भने के हुन्छ it will give hydronium ion 1 right so basicity of this acid is 1 हैन okay and so this is strong acid किनभने you easily ionize हुन्छ it easily gives H3O plus ion so it is a strong acid. Now next is it react with HCl NH3 gas अब जस्तै तिमीले when you do the inorganic that qualitative analysis okay so that time whenever you do the conformatic test for your group 1 okay group 1 ions like timro basic ions group 1 ma ammonium ion cha so whenever you do the test okay so that time you heat sodium hydroxide with ammonium hydroxide भयो and when you do the heating then what happen is like it gives out garcha NH3 which have rotten egg like smell हैन and when you dip your rod HCl मा dip गरेर when you bring this rod near to the test tube okay जहाँबाट चाहिँ NH3 आउँदै गरेको हुन्छ so NH3 निक्लिँदै गरेको हुन्छ rod मा तिम्रो को छ HCl हुन्छ र what happen is fumes त हुन्छ NH3 को so जब HCl मा dip गरेर when you bring that rod near to the test tube you will get is a white dense fume के पाउँछ white dense fume and that is because of formation of ammonium chloride भन्नुको मतलब your NH3 combined with HCl to give ammonium chloride which is your dense white fume. Now next aquaresia हैन. So this is a strong acid यो जुन चाहिँ mixture छ, it's a mixture of HCl and HNO3, right, in 3:1 ratio र जुन पाउँछ that is your aquaresia. Okay, र this is very strong your solution, okay, acidic solution, and it even dissolves your noble elements like gold, platinum. Just the gold, platinum, it won't dissolve in nitric acid or it won't dissolve in HCl alone, but with the mixture, this mixture will dissolve your noble, even noble elements. किन भन्दाखेरि okay, there's no space. यहाँ के हुन्छ तिम्रो gold, okay, so hydrogen cha, right, nitric acid, mixture of your nitric acid and HCl भनेपछि hydrogen त both मा common छ, nitrate ion आउँछ र HCl बाट chloride ion आउँछ, right, the two will mix and will give a complex, okay, AuCl4 minus, and this is your soluble complex र NO, okay, plus 2H2O. So NO will be in this complex only. अर्को नि platinum, okay, 16 your nitric acid cha, your NO3 minus huncha, so Cl minus huncha, HCl cha, right, again it form a complex, so PtCl6 2 minus 4 NO plus H2O, and now because of this complex, soluble complex, so your के हुँदैछ यता यो डिजल्भ हुँदैछ भयो. डिजल्भ किन भएको भन्दा तिम्रो यो सल्युबल कम्प्लेक्स फर्म गर्छ. नाउ नेक्स्ट इज oxo acids of fluorine. तिम्रो so this your halogen form oxo acids. There are many, right? So fluorine form only one oxo acid. Why? किनभने यसको एउटा त small size छ. Okay. One is it is highly electronegative, right? Highly electronegative. अर्को छ यसको 3 मा absence of d orbital, absence of d orbital. So for that reason fluorine forms only one oxo acid, and that is HOF, hypofluorous acid. यसलाई के भन्छ, hypofluorous acid or fluoric acid पनि भन्छ भयो. अन्त now तिम्रो most of the oxo acids, so it cannot be isolated in pure state, decompose भइहाल्छ र so they are stable only in aqueous solution or in form of their salt. Now some oxo acids तिम्रो hypochlorous acid, okay, chlorous acid, chloric acid, perchloric acid. ठीक छ. now यसको structure के हुन्छ, so all will have tetrahedral structure, because all have not tetrahedral, distorted, but it will all will have a hybridization state sp3. so structure हुन्छ for this bent like structure, okay, and this one HCl, there is 2, right, Cl, then Cl, H, then oxygen, एउटा, then दुईटा, okay, lone pair छ, then your this one Cl, how many are there? 4, 1 2 3 4. so your oxygen, hydrogen, then rest is your oxygen. Okay, so these are the structure for some oxo acids of chlorine. Now the acidic strength of this oxide with increase in the oxidation number of your chlorine. So that means your HOCl less acidic than HClO2, then less acidic than HClO3, and less acidic. So perchloric acid is the most acidic your oxo acid. Now, so for the oxo acids with same oxidation number of halide follow this order. HClO4 is more acidic, okay, and HBrO4, and HiO4 is less acidic. So as we know that on moving down the group, what happen is metallic character increases, right, because of increase in the atomic size or decrease in the ionization enthalpy. The metallic oxide के हुन्छ प्राय जस्तो it is your basic in nature. So for this reason, what happen is on moving down the group, the acidic strength of this oxoacids with same number of oxidation number of halide will decreases in this order. Now next is your oxidizing power of oxoacids of chlorine follows the order HClO4, then now order follows the order HClO4, HClO3, HClO2, HClO. So hypochlorous acid is a strong oxidizing agent. Now what is the reason? So oxidizing, what is oxidizing power? So oxidizing power means it is power, right, property to oxidize the other element, right, or it is how it oxidizes the other element by taking the electrons, right. Now what happen is like if you see the oxidation number, right, so the oxidation number of this is very high, like यहाँ कति छ यसको छ +1, then यता छ +3, then here the oxidation number of chlorine is +5, and here the oxidation number of your chlorine is +7. Now अब तिम्रो के हुन्छ भन्दाखेरि these are the cations. So size, if you compare the size of the cation, Cl plus Cl3 हैन plus के हुन्छ भने Cl+7 को size is very very small. So because of that तिम्रो, if the size of cation is very small, then its polarizing effect will increase. भनेपछि यसले इलेक्ट्रोन के गर्छ मजाले तानिहाल्छ. So भन्नुको मतलब अब यसले what is oxidizing power is your electron gaining tendency. Oxidizing power भनेको नै के हो, electron gaining tendency, because it help other to get oxidized, हैन. So त्यसले गर्दाखेरि अब once यसको because of the small size and because of the high polarizing effect, okay, of this chlorine, so यसको यो जुन चाहिँ +7 चार्ज छ or positive चार्ज छ त्यो compensate भइहाल्छ. So that means it जुन चाहिँ positiveness or जुन चाहिँ electron gaining tendency छ यसको के हुन्छ पहिला नै compensate हुन्छ. For that reason that electron gain tendency यसको कम्ती हुन्छ compared to this one, where this will have a less polarizing effect compared to this. बुझ्यो कि बुझेन? Now the last topic is interhalogen compounds, as we have already discussed. So these are the compound among the halogen. So it have the formula like XX dash, then the XX dash 3, XX dash 5, XX dash 7. Now example CLF3, okay, then BRF5, त्यसरी नै IF7. Now यहाँ के हुनु छ, यो यता के हुन्छ भने x र x dash को there will be large difference, okay, in atomic size. Atomic size भनेपछि अब तिम्रो size of your x को के हुनु पर्यो greater हुनु पर्यो than that of x dash. So it can easily accommodate, right, this around its space. So त्यसले गर्दा जहिले पनि interhalogen compound मा दुईजनाको एउटा साइज डिफरेन्स हुन्छ. एट द सेम टाइम देयर विल बी अ डिफरेन्स अफ इलेक्ट्रोनेगेटिभिटी. दुईजनाको साइज डिफरेन्स हुन्छ भन्दाखेरि चाहिँ डिफरेन्ट हुन्छ भनेपछि इलेक्ट्रोनेगेटिभिटी पनि डिफरेन्ट हुन्छ. एन्ड एभ्री टाइम योर सेन्ट्रल एटम जुन चाहिँ छ लाइक यता एक्स इज द सेन्ट्रल एटम, ओके, इट शुड have larger atomic size, okay. Now next is preparation. So your interhalogen compound so can be prepared by direct combination, okay, of your halogen or by action of halogen with lower interhalogen compounds. Just say ClF C2 and F2 in 1:1 ratio, equimolar ratio, it will give ClF, okay, and I2 just a direct combination of Cl2, so it give ICl3 1:3 ratio ma cha yo, okay. Now त्यसरी नै I2Cl2 1:1 ratio ma, or so it is Cl2 F2 excess ma, so it will give is ClF3. Br2 plus F2, okay, so it give BrF5 in 1:1 ratio. So if it is in excess, So your interhalogen compound properties man, they are covalent, they are diamagnetic in nature, volatile solid or liquid huncha, and properties जुन चाहिँ छ. Okay, so it will between those of the constituent particles, like suppose if your compound is of chlorine and fluorine, so जुन चाहिँ proper physical properties हरू जति चाहिँ property यिनीहरू दुईजनाको intermediate हुन्छ, except their melting point, boiling point भयो. So जुन चाहिँ melting point र boiling point चाहिँ so interhalogen को अलिकति higher हुन्छ than expected, र अर्को interhalogen compound are more reactive than halogen. So if ICl, okay, is more reactive than I2, and यो दुईजनाको reason को लागि answer is same. जस्तै when we talk about ICl, okay, so there is a difference in the size, right? Electronegativity पनि different छ हैन. जस्तै यता Cl, okay, so Cl is more electronegative than iodine, so that means it will pull electron cloud toward itself, so it will acquire partial negative charge, it will acquire partial positive charge. So dipole के हुन्छ भन्दाखेरि now because of dipole interaction, just ICl, if there are number of ICl, so positive negative charge को बीचमा के हुन्छ, attraction हुन्छ, and because of this dipole interaction यिनीहरुको boiling point, melting point ज्यादा हुन्छ than the constituent. Just the I2 मात्रै छ भने के हुन्छ? Now I2 is what? So I here the electronegativity difference is 0 भयो भनेपछि यता कुनै चार्जहरु partial चार्जहरु केही acquire गर्दैन. So this is your neutral. So neutral मा के हुन्छ भन्दा van der Waals force van der Waals force हुन्छ, right? And that van der Waals force interaction is weaker than your dipole interaction. So for this reason अब यो के हुन्छ, weakly bound छ. So that means it will it have very low it have a low melting point, boiling point with the corresponding interhalogen compound. Reactive मा पनि same reason no. Now because of this, right, one will acquire partial negative charge, one will acquire partial positive charge, so यो bond polar हुन्छ, so slightly ionic हुन्छ. Okay, so polar bond so यता like if you see the electron distribution between this bond, chlorine ले के लान्छ, अलिकति बेसी electron लान्छ than iodine को मा अलिकति, जुन चाहिँ यो bond छ. Okay, this is what you will get, or it become polar, and that means polar bond के छ, it is easy to break, whereas so this is purely covalent. Okay, and covalent bond is very strong bond, so त्यसले गर्दाखेरि यो easily break हुँदैन. So therefore this is less reactive भयो. So तिम्रो reactive हुनुको लागि first it have to break the bond between it, then only the reaction occur. All interhalogen compound will undergo hydrolysis, okay, to give hydrogen halide, hypohalite. Okay, suppose your formula if it is different, X ले halite दिन्छ, त्यहाँदेखि XX dash ले halate, then per halate त्यसरी नै. Now last is uses. So it is used as non-aqueous solvent, okay, and it is used as a fluorinating agent, like for reaction uranium लाई fluorinate गर्नुको लागि interhalogen compound use गर्छ. Okay, so what you will get is fluorinated uranium and your CLF. So interhalogen, one of the important uses, it acts as a fluorinating agent. Thank you all.